Hello, I'm Rital and my teammates that will be presenting with me are Lujain, Jana, Noura and Lama. I'll begin by introducing the focus and the purpose of our project. The table of contents in our presentation include introduction, problem description, objectives, input data, simulation model, results and analysis, and finally conclusion and recommendations. Theme parks are magical places where excitement and joy come to life. They offer thrilling rides and unforgettable experiences, but behind the fun is a complex system that keeps everything running smoothly. A critical part of this system is the entry process, which sets the tone for the visitor's entire experience. In our project, we focused on optimizing the entry process at AlShallal theme park in Jeddah, specifically the ticketing and bracelet counters. These are the first touch points for visitors when they arrive. The entry process begins at the ticket counters, which operate from 4 p.m. to 1:30 a.m. Visitors queue in two separate lines, managed by 7 employees, to purchase tickets efficiently. After getting their tickets, visitors proceed to the bracelet counters, which use a shared queue feeding into two counters. Here, 3 employees issue wristbands and allow visitors to load points for games and attractions. Once done, visitors enter the main park to enjoy the activities. While this system works well at times, bottlenecks often occur during peak hours due to capacity differences between the counters. These delays can impact visitor satisfaction.
The specific problem in this study revolves around managing visitor flow and minimizing delays and waiting times at the entry points at Shalal theme park on Women's Day only, particularly at the ticketing and wristband counters. Currently, visitors face delays due to bottlenecks in these areas, which can result in frustration and a negative start to their park experience. Poor resource allocation, such as having too few service counters or inadequate staffing during peak times, increases the problem, leading to long queues and overcrowding. These inefficiencies not only impact the visitor satisfaction but also reduce the overall operational effectiveness of the theme park.
The goal of this study is to assess how well the ticketing and access band system works at a Shalal theme park on Women's Day. It focuses on finding problems and delays in the process that cause long waiting times, using simulation tools. The study will test the effect of changes like adding more staff or service counters. Finally, it will recommend the best solution to make the system faster and more efficient.
The data for this project was collected through interviews with an administrative staff member at Shalal theme park, and also the team visited the theme park on Women's Day only. The following tables show the data that we used to simulate the system. For the current method, first it was validated using the trace method. The entities were tracked from entering to leaving the system. So 1,381 entities entered, but only 811 exited, meaning they faced bottlenecks and that prevented them from moving to the charging counters.
In the proposed system, we implemented a work schedule to increase the capacity of the staff during peak hours. We also recommended adding self-charging machines. By implementing this solution, we observed significant improvements. The entities were no longer blocked from the charging stations, addressing one of the main bottlenecks. For the results and analysis, we observed a decrease in the utilization of servers, which indicates reduced fatigue for the staff. Another significant finding was that in the current system, 570 entities were unable to exit the system and enjoy the park. However, in the proposed system, this number dropped dramatically to only 11. Additionally, we noticed improvements in the average holding time for ticket servers, while the bracelet service did not show a major improvement in this metric. To conclude this presentation, we analyzed AlShallal theme park system and identified issues with the flow in the ticketing and bracelet charging processes, specifically in Women's Day. By simulating the system using Simu software, we pinpointed the primary problem, which is an insufficient number of bracelet charging stations. Using the software, we developed a solution by increasing staff during peak hours and recommended that the theme park implement this change from 5 p.m. to 12 a.m. We also suggested adding permanent self-charging stations to further alleviate congestion and improve the overall flow of the system.